Hey calculates, so as you work through these related rates problems, before you watch the video section for each one, you need to stop the video and attempt to draw the diagrams, because about 75% of the problem really comes from you drawing the diagram correctly. And if you don't, you really can't set it up. So in this particular problem, of course, I have an inverted cone, so I've drawn that. And it tells me that it has a radius of 2 and a height of 4, so I've labeled that. Now, that doesn't mean that that's how high the water is going to be when it's pumping in. As a matter of fact, I can see that it's not. But what it does allow me is to write a comparison of those two lengths to each other. So you'll see I have it set up here in a proportion form. So the comparison of radius over height is equal to 2 to 4. And then I can do some fancy mathematics and figure out for either variable. So if I were solving for h, I'd divide by 2. If I were solving for r, I'd divide by 4. I'm actually going to solve for r, so it'll be 1/2 height, or height over 2. Okay, so next, of course I'm pumping water into it, so I can tell by the measurement or the fact that just my own knowledge, I know pumping water in is referring to volume. So I need the volume formula for a cone. I'm going to start with that. And then I'd like to have this volume formula in terms of a single variable, which is why this comparison over here comes in so handy, because I can do substitution. Now, I actually paid attention to the question, which it said, find the rate at which the water level is rising. So that has to do with the height. I'm looking at water going up, so I'm looking at the change in height. So I'd like that formula to be in terms of height. So that means R, you gots to come out of there so that I can put an H in. So when I do that, then I get 1/3 pi still, but in place of the r, I'm putting the 1/2 h, and then I'm going to simplify it out, so I'll have 1/3 pi, and then a 1/4 h squared times h, and that of course all simplifies to 1/12 pi h cubed. And so that's what I'm going to take my derivative of, because of course I need to have dh dt involved in here somewhere. So the derivative with respect to time, because I can tell, oh by the way, the time is minutes, so I have 1/12 pi. Now remember, the coefficient just hangs out in front until the variable does his thing. So 1/12 pi is going to sit here and wait for h to do his thing, which is power down and take the derivative of the variable. And of course I could simplify the 3 and the 12, so I really just have 1/4 pi h squared dh dt. Okay, so now I actually knew this dv dt amount because that was given to me. It's 2, so I can substitute that in. And then the only variable I have left to solve for, oh, whoops, sorry, I forgot. I do have one other piece. When the water is 3 meters deep. So I don't get to use all that height. It's only filling up to 3 meters worth. So that means at my freeze moment in time, I actually know height is 3. So I'm going to substitute that in for h. And then I'll finish the math magic, pause the video, see if you can work that all out by yourself for dh dt. So check your answer and see if you got 8/9 pi, and of course I labeled it meters per minute, and that's my change in height. On to the next problem.